Okay, I forgot. Sorry, I forgot the mic. Now it's turned on. So yep. I was just saying I'm gonna post on Twitter for a second and just let everyone know that we are live, and then we're gonna pick up from where we left off yesterday. Also, there is also a thunderstorm going on right now. Just got a flood warning, so the power might go out here. Just a word of warning. All right, so we can go ahead and get started now. So actually what I want to do is talk about the code from yesterday. I finally figured out what the problem was. And actually it was all in the... So it was funny because after it was done, Ezra, XRA on Twitter, he's working on Memory of a Broken Dimension. He's the one that gave me the example code that helped me figure out how to work with a grab pass. And he was saying, you know, we were basically getting a bunch of weird edges yesterday. Let me actually do a quick refresh of what was done yesterday. I think this is the script. Right, so basically let's go to the camera and enable it. Okay, so yesterday, basically, I talked about how there are certain shader artifacts that comes about. Also, we might have Ezra doing the game design, come on the game design critique streams sometime next month, talking about Memory of a Broken Dimension. So that would, you know, I really want to talk to him about some of the shader stuff that he is doing and what the process has been like for him. So I think that would be of interest for a lot of you. So, you know, as I was saying yesterday, basically I have these two boxes, and there's that hidden face on the inside, which causes my edge detection shader. There's like a there is a okay, I'll bring the mic a little bit closer. So there is basically this this gap, even when they're close together. Interesting. My ProGrids window isn't enabled by default for some reason. Let's actually save this as stream layout. It is really pouring outside. So so basically there doesn't look like a gap here, but there is like a floating point error. There's basically a 1 pixel wide gap that the edge detection shader picks up, and we get these artifacts as a result. So the idea yesterday was to, and now the way the edge detection works is that it takes the depth values and the normal values, and we compare them to see, for each pixel we compare the depth and the normal values of the surrounding pixels. If they are very different, then we would Alright, the video just cut out for me, but it is like really pouring outside. So, right, so we compare, so for each pixel we sample the surrounding pixels and then see if the normal values or the depth values are very different. Okay, then there was just me, right? And then if the values are very different, then what we do is we say that it's an edge. And if not, then it's not an edge. So I know that the artifacts are being caused by the normal values because I can kind of turn off the depth test or the normal test, and when it's just a depth, those artifacts don't show up. So I know it's due to the normal values, right? So the strategy yesterday was I thought what we could do is blur the normal map using. So we would do a Gaussian blur on the normal map, and the idea would be that we blur it just enough that, you know, it's not we're not really seeing that difference. And then what we do is we use those colors, the blurred colors, as well as the depth, the non-blurred depth, to do edge detection. And yesterday we were having a bunch of problems with the lines. And it turns out, and as it turns out, the answer was actually in the solution from the example text that, no, you know what I think happened was I think it just gave me quality configuration. So it like, I think there's enough people watching that Twitch has allowed you to adjust quality of the stream, and basically every time it switches into that mode, the stream like cuts out for a second. So this is, I'll show you guys what it was looking like yesterday, and then I will explain the problem. Actually, need to... Oh no, okay, it hasn't happened. Then maybe it was just my internet. Alright, so this is what we were getting in our... So this is what the normal values look like. And let's click on the main camera. So if we start... No, wait, wrong. That's the wrong script. Here. Okay, so yeah, you can see in this we're starting to apply the blur power. I think part of it is also that the blur method isn't really correct, because right now it's actually, it's like not so much, how do I say this? So for example, if you look at those stairs, right, if you look at this blue stuff here, between the green, even when we increase the blue power, that's sort of still there. So I don't think, well, I think part of the issue is we are not doing Gaussian blur correctly, right? But the idea was that it would kind of hide out for the little pixels of normal values that are different, that the blur would get rid of them. And we were doing, where is our edge detection? All right, now let's just go into play and see what the edges look like. So yeah, yesterday I remember we were having this weird bug and I didn't get this thing working, and then afterwards I took a look at it and did figure it out. So anyway, you can see we're applying the blur. Now I'm a little bit confused as to why the edges are not being drawn. And right, so Ezra suggested actually explicitly spelling out this into a if-else, into an actual conditional. Okay. Hold on a second. I think I know what the issue is. It's because I wasn't... Yeah, there we go. Right, so like basically what we're doing here is we are getting the difference in the normals, and if they are less than the normal color sensitivity threshold, it could also be that I've disabled it in my past. No, that is correct. All right, I totally had this working yesterday, so let's just kind of look through this. I think it'd be a good chance to review for people who are new as well. Basically, what this script is doing, first we grab the normals. So for there, we're using the camera depth normal texture from Unity. What we do is we grab each depth value. So we're sampling a number of different units, right? And what we do is we get the depth and normal values. First, we have to decode camera depth normal texture to grab the normal values because it's stored in a way that isn't usable immediately. So first you have to decode it, and what it does is you put it in this function, and it takes the camera depth normal texture, it looks at the position, you've set it here, and then it puts the depth value here in this variable, and then it puts the normal values here in this variable. So once we have the normal values and the depth values, we blur the normal values. So we're not using the depth value here. We blur the normal values, and then what we do, and we are blurring it in the vertical direction. So you can see the offset is in the y axis. They all have the same x coordinate value. These all have different y coordinate values. So the offset by a unit times the blur size. Hey, hey, David Kilmer. So then what we do is we do grab pass, and what grab pass does is it grabs the, it takes whatever's being drawn at the time by the last pass and uses that. So we do grab pass, and then here we got to set sampler 2D. It's the grab texture, and what we are doing is we are taking the then we're blurring it in the horizontal direction. And the reason why we're doing it in two separate passes, because you're saying, well, why don't you blur them vertically and then blur them horizontally? It's actually because you would have to do, if you were doing it horizontal and vertically, like in a square size sample, you would have to do, let's say this is like 5 by 5, right? No, wait. 1, 2, 3, 4, 5, 6. No, this is 9 by 9, right? Because we're combining the normal values from 9 different samples. I think, it is. I'm just not sure if that's like if you would say that's 9 or 4. But anyway, let's just say it's 9. So right. So what we're doing is we actually would be sampling 9 by 9 times equals to 81. So you'd be sampling 81 times for every call, for every pixel, and that can get pretty expensive. And so if you just do it in one axis, right, you would be doing 8 call. You'd be doing, well, 8. Actually, so yeah, you would be basically doing, like, if you were to do it in a square, you'd be doing 64 calls per pixel. Here, what we're doing is we're actually doing 8 calls in one pass and then 8 calls in another. So that's actually, this is a pretty common way of optimizing your Gaussian blur, splitting it up into 2 passes, and then you go from, n squared number of passes down to n times 2. So I guess that means if you're only sampling like 2 pixels, then it doesn't matter if you are doing it in 1 pass or 2 passes. So anyway, what we're doing here is we're blurring it horizontally. So now you can see it's the x coordinate that's getting offset, and the y coordinate is all the same. these are the Gaussian coefficients, which we determined from this website. It's basically just so that you create this kind of distribution with the colors. And I don't think I'm doing it right. No, I mean, like, I need to do multiple passes. But anyway, what we then do is after we've blurred it vertically and then after we've blurred it horizontally, we grab pass again, we grab the texture. Now what we're grabbing is the blurred normal texture. Yes. So the grab pass is taking what the previous pass generated. And now what you can see, what we're doing is, so we've got the grab texture and the camera depth normal texture again. Because remember, what we want is the blurred normals, which are right now stored in the grab texture, and the non-blurred depth, which is in the camera depth normal texture. So, okay. So now in this one, we are comparing two normals to see if they are the same. We're comparing two depth values to see if they're the same. Now, so if the normals are small enough, right, it's basically saying, like, what we're doing is we're getting two normal values. We get the absolute value of the difference, right? And then all we're doing is we add the x, the y, and the z coordinate of the difference. Because if two values are close together, then this difference would be very close to 0, 0, 0. So that means if you add up the x and the y and the z coordinate, it would be very close to 0. So that gives you that. From there, you can get a measurement of the size of the difference. And if the difference is very small, if it's less than this threshold number we've set, then we would say that it is the same normal, and therefore it's not an edge. And if it's much bigger, then this statement is no longer true, and it would return 0. So it returns 1, meaning that yes, the normals are the same, or it returns 0, which is saying that the normals are not the same. Hey, Garlando Bloom, Matthew. So yeah, we're basically doing the same thing here, but we're doing check depth values. So now let me try to, I'm sort of trying to recreate the problem that we had yesterday. Because I think it's a good lesson there. Right, so here you see we're getting the samples, which are pulling from the get depth normal texture. We decode it, so we're getting the depth values from the depth normal texture, but the normals we're not getting from this. We're actually getting it from, we're taking the color values from graph texture. So values are close. So here we are doing the check same normal to see if it's an edge or not, and we also do check depth. But anyway, we set the edge color to white. There is your original color, which is the background color. There's a grab text color, which is what the grab texture looks like, which in this case is the blurred normals. If values are close, we return grab texture. Otherwise, we return edge color. So what I am a little bit confused about is that we should be seeing some edges right now. And I don't know why we are not. But so anyway, actually let's go ahead and return edge color. This is just a way to test. So that's the thing with shader debugging. Hey, yeah, sorry, we changed it to William Chyr. And actually, the game is going to be renamed as well. We just haven't fully announced the new name change. So that's going to be in September. I actually wanted to do it today, but we didn't have everything ready. So the name of the game is changing, and yes, William Chyr's Totally Professional Game Studio. This is definitely not my living room that I am working in. Okay, see, this is interesting now. It's not... We're actually not getting the normals? What the fuck? See, if everything were working, we would actually be getting... You know what? It's because this has some bugs, so we need to fix this one first. Actually going to call it Mieka Kure. Antechamber 2 is the new name. What the heck? Alright, so this is weird. I think it's a... Grab past normal blur edge detect, right? That is grab past normal blur edge detect. Actually, let me do something. Return half for 1000. So what we should do is what we should see is the screen should be red. Interesting. Ah. Actually, this should be commented out. Okay, it's, you know what, it looks like we had some errors and it wasn't rendering. Okay, let me fix float. Okay, so these should not be float 3. Alright. Now, this is very bizarre. I'm not sure why the shader isn't responding. Relativity Chyr. William Chyr's Escher Highly Distinguished Game Development Corporation. Oh man, I don't... I'm gonna do the thing where I close Unity and hope that it gets fixed. That was my super profesh debugging method, which is just to turn off, like, quit Unity and open it again and see if it fixes stuff. Okay, so fuck. It's because this wasn't. It was another shader that was on the material. This is what happens when you have too many shaders that are all named like too similarly. Yeah, so you can see I have like grab has normal texture, so yeah. Well, okay, so the thing with the Sid Meier style thing with putting the name in the title, what's really weird is it just gets really awkward in all the articles because they're like, hey, we're hanging out with Willie Chyr talking about Willie Chyr's Relativity, and no one did that. And there's also like, it'll get confusing when people search for the name of the game. You know, you just want to make it a lot easier. So I'm pretty happy with the new one. Anyway, so that was really stupid on my part. It just turns out we just had the wrong shader attached there. So, you know, let's go back. okay, so that was, we were just looking at the wrong shader. I mean, the thing that I was confused about is because that one had the normal, that one had the normal blur. It didn't have the second part, which is, so it's not totally. It's not totally ridiculous that I was getting confused. So yeah, you know what? We are not going to return this value, and that should be working. What the heck? Ah, right. So that's our, okay. So this is the reason why it's returning white. So it should return red now. There we go. Right. So now we know the problem. So the problem we were having yesterday. This is what was going on, right? Yeah. Okay. So for some reason it was doing this, right? It was like instead of actually drawing edges, it was like going between the blur mode and then going between this. Main GI. Unfortunately, I actually cannot change. I would totally change my YouTube URL, except YouTube doesn't let you do it unless you have at least 500 like subscribers. Change YouTube URL. Yeah. So see, channel custom URL, eligibility requirements. You need to you need to have 500 or more subscribers, and currently I only have 104 subscribers. So but anyway, so anyway, this was kind of where we left off yesterday. This like really confusing problem. And there are actually a number of things here that's wrong with it. So the first is we were actually using the main texture texel size to grab our sample distance, and this actually should actually be this. Wait a minute, hold on a second. Let me try one thing. Actually, I'm just wondering if maybe it should be this like main texel size, if that makes a difference. Because I was under the impression that main texel size and main text st are the same, but let's hey, thank you, Boston, Mass. Yeah, I don't know if the st thing is actually correct. So anyway, that was where the problem was. Times sample distance. So let's see if this works. Okay, yeah, so it's not working. So, oh no, wait. Oh. So yeah, it is, though it does look a little off. Wait, that's probably just our blur thing. Right. So, it seemed like, I don't know what, yeah, it also complicates things because it's attached to a Google Plus account, but, I don't know. I mean, I don't really use YouTube. Right. Yeah, YouTube is too confusing, but I mean, mostly it's just Twitter and Twitch. So anyway, as you can see, so that was the problem. I actually also had it be this. So actually, I don't know what. Actually, you know, now would be a good time to figure out what this main text st thing is. What is main text st? They represent texture, scale, and texture offset. Like, I guess the question really should be main text st versus main text textile size. Main text textile size, what is the meaning? It's set by the application if it's present in the shader. It's the size of a textile of the texture in question. In other words, if it's a 1K by 1K texture, both X and Y will be 1.0 out of 1024. I see. Okay, so it looks like, so I guess usually there's like a, there should be a shader thing that anyway, I thought, so it looks like textile size is the textile size, and then main text st is actually scale and offset. So I shouldn't have been using them. So I thought they were like replaceable, but that doesn't seem to be the case. Okay, for each texture property, Unity offers such a vec4 uniform with the ending st. Remember, s and t are the official names of the texture coordinates, which are usually called u and v, or x and y. The uniform holds the x and y components of the tiling parameter in main text st.x and main text st.y, while the... Okay. Yeah, it's right. So I said so I did say it did well, okay, so as it turns out, the grab texture, so it was this line that was the problem, right? But as it turns out, grab texture textile size also works because grab texture textile size is the same as main texture textile size, so that was what like, yeah, you can see now it's actually giving me, this looks exactly the same as when you're using main text textile size. So we're getting the exact same results because I think the textile size values is the same. So yeah, I'm still not super sure what. Yeah, okay, so I guess it's the tiling and offset. These parameters allow you to repeat the texture by shrinking the texture image. Oh, I see. Right. Yeah, okay. So it is... Okay. Yeah, you know what? Right. It wasn't so much that... So David, just to correct what I said yesterday, it's not just... It's not necessarily that I had to use grab texture textile size. The problem yesterday was actually I didn't know that there was a difference between main text st and main text textile size. So main text textile size is the size of the textile. So I think that's like, you know, 1 out of whatever your coordinate, your dimension is, and main text st is actually the tiling and offset parameters. So of course we were using main text st to calculate, you know, the sampling distance, so that got everything screwed up. So anyway, I'm gonna come back here to this and walk around a bit. Oh, so actually, while a bunch of you are here, I think starting tomorrow, not tomorrow, maybe starting next week or the week after, I think I'm gonna pick a day, maybe Wednesday, and stream. Instead of streaming at night, I'm going to stream in the evening. No. Instead of streaming in the evening, I'm going to stream in the afternoon. So right now I'm starting at 8:30 p.m. Central Time and going until around 10 p.m. And I think starting next week I'm gonna pick a day in the middle of the week, and stream from 2:30 p.m. to 4 p.m. because that would be like UK time, 8 p.m. UK time. So because I've gotten some some people have told me that it's actually some people have told me that the schedule is actually really hard for them in the UK, because right now it's like 2:30 in the morning. So one thing you'll notice here is that we are actually upside down, and that's actually due to this. This script isn't there, so basically you want to, yeah, if the UV starts at top, you just want to invert. No, wait, actually it's not even this that okay, so this is actually kind of funny. So first of all, what we want to do is we want to invert what the fuck? One of these should be inverted. Oh, there we go. You're right. That we needed to invert that. Oh, I know. Well, what I wanted to show you guys was, yeah, it's 3 a.m. in the UK right now. So I wanna do it 6 hours earlier. So it'd be like 2:30 p.m. in the UK when it starts. So basically this is what happened was. So you can see we are in this script up here in the shader. We're inverting the. We need to make sure that the textile starts on the correct side. Megaspell says you wouldn't mind playing an upside down game. Apparently your brain flips your vision, and when you see the world the right side up, it actually looks upside down to you. So anyway, this is actually, when I got it working, this is what it looked like at first, and I got super confused because I was like, I don't understand. Yeah, I was like, what the? I mean, this looks really cool, but it also, right? Like this looks pretty awesome. But it is giving me a bit of a headache. But the red lines on green looks really neat. Anyway, so you can see we have the you can see a bunch of the artifacts there, and if we increase blur, you see those artifacts, you can see them down here. You guys can see this? Let me know if it's showing up in the stream. Notice that so blurring does indeed get rid of them, but it does come at the expense of the lines. So it's like the lines are already super thick. You know, you're already seeing double with the lines. But hey, Lighter Thief, how's it going? And Meta Real World, welcome back. Yeah, so anyway, now let's jump back into the. So anyway, it turned out what I had to do was actually flip the samples as well. And actually, now I realize why why my other thing didn't work. Yeah, it is visible. But don't worry, today I have one more. So unfortunately, it didn't work, right? This blurring. I think it's a combination of the blur not being very good. But actually, if you play Antichamber, it has a bunch of those artifacts as well. So like some time ago, when I first started doing orthographic images, I was getting a bunch of images like this, which looked super weird. And now I realize what's going on was that the values were the depth. We were inverting the depth values and not some of the other ones. So we were like separating the passes, which is what was going on here. Well, I did think they looked super cool. So I am keeping them, but yeah, that was the problem. And for a long time, I didn't really understand what was going on. I didn't know something was being flipped, but now it's like, I know. Now I know what's going on. Yeah. So the thing with the Antichamber edge detection is that Alex told me he's actually only using depth value there. So if you play Antichamber, the view distance is a lot smaller. There are almost very few outdoor scenes. In fact, there's only one outdoor scene, and the view distance is quite small. So, but he's only using depth. He's not using normal. So the edge detection in this game is actually a lot more precise. So yeah, let's walk around. So this is now it's the corrected version. Right, I mean in a scene with a lot of stuff going on. I'm gonna take some screenshots from this. So anyway, this is so yeah, unfortunately you can still see that it's right here. But yeah, you can still see there's a ton of these artifacts. So I just need to post on Twitter, let people know we were still streaming. Okay, TweetDeck is like so stupidly slow these days. I don't know what's going on. Oh, by the way, on Friday we are going to do the game design critique stream, which is what we've been doing every Friday, and this time we are going to have Brigador which is the game by Stellar Jockeys. They are based, 3 of them are based in Champaign, Illinois, which is just south of a town south of Chicago. And yeah, I'm super excited about this game. We are going to, it's coming out in early access later this year, but it is looking really, really great. And it is the game that we will be checking out on Friday. Anyway, we won't watch the trailer right now. So, let's see. Yeah, the diagonals in an antechamber, you can see them. They're very noticeable. I'm not really sure why we are checking the normals rendering to generate the outlines. How are we... What do you mean by the question of the normals? Well... Yeah... I guess I've been working on this game, so this is to answer Medium Unwell's question. I've been working on this for about 3 years now, and it, like, I kind of been tweaking shaders for 2 years, and it was only until now, like this time I really, really understand what I'm doing. Why aren't you working in the inverted with white-black scene? Is something different about this? I'm not sure which one you were talking about in main GI. Alright, okay. Oh, and by the way, if you are new and you enjoy the stream, make sure to follow. We changed channels recently. So anyway, this didn't seem to work really well. That was my theory. So my next theory is this, and I will explain with... yeah. No, I was just, I can display that, right? You can say, main GI, that's actually pretty simple. Like, I can actually just change it right here. We can just say the edge color is black. And we can just say, we can change half for white color equal... Photoshop's that trying to take over. For 1, 1, 1, 1, and then we would just return white color. Yeah, so see, there you go. I mean, I'm not gonna throw in the towel, right? That's like, it's not what we've been doing. Like, I have been refining this edge detection shader for like 2 years now, and it is really good. So we're definitely not throwing in the towel. We're just, yeah, the normal is the direction that the plane is facing, right? So if we look at it. Right, so like, we're basically, this is the normal of this face. It's going up. The side face, it's going this way. And what we do is, so it's a 3 vector. It's a vector with 3 coordinates. And what we do is we just put them on the RGB, and so you can get a color from that. So yeah, I mean, basically, these would all, everything here has all the same normals. These have all the same normals. So you know, if 2 pixels then have different normals, then you know that there's probably an edge in between. I'm gonna get some iced tea. I'll be right back. Adjusting the threshold for edge detection higher. Let's see, right? So, where are we? Where are we? Blur power. So yeah, you see, we've gotten rid of the. At this point, we get rid of the edges. Yeah, at this point, the threshold doesn't really matter. Yeah. See, at this point, the threshold doesn't actually make much of a difference. It's partly, it's also the blur. All right, let's take a look at that. I wanted to... So the reason why I'm showing the blur... hey, Medium Unwell, what are you talking about? How long did I study until I had the confidence to start working on it in the first place? Regarding the game actually started as a way to learn Unity. I had another idea for this, like, cyberpunk MMO set in Chicago. And I was like, well, maybe I should make a small project to learn Unity. And 3 years later, here I am. So, right, the reason why we're doing this is so I can, like, I can see the blurring here. But yeah, you see that? Like, look at these. Look at that. And I guess if we, now if we lower it, it does help a bit. Right? It does help a bit, but we're still getting those blurred lines. Oh man, that looks cool. What? Oh man, oh shit. I think this is just what what's his name is doing. Memory of a Broken Dimension. Ugh. Alright, so anyway, let's stop working on that. So this is what I'm thinking is going to work. Okay. So let's say this is blue is our center. All right. Actually, I am going to sit down. So I'm going to lower my desk. Okay, so let's say this is our pixel, right? That's the main pixel we're looking at right now. Now, when we do the sampling, we're sampling the pixels directly here. Now, my theory is that what's going on is we are actually picking up what's going on is I think these are also, okay. So this is sampling, right? Let me do another color thing. So this is our sampling, and basically the blue is the pixel in the center. That's the one we're looking at. What we're doing, so our question with the edge detection shader is blue an edge or not? And what we are doing is, oh yeah, David, you can do that, right? You can basically do what we've done, right? You detect the edge, and then instead of showing the edge color, you would just take another texture and then put the color, instead of returning edge color, you return color from that texture that you want. Oh shit, that's actually kind of cool. Like we could do oh my god. hold on a second. Wait a minute. So see, you can, instead of edge color being this, we can say half for edge color equals to half for, I don't know if this will work. I dot uv0 dot x. I think of using the x coordinate as, this might not work. So basically I wanted to like blend it, but you could totally, is it working? Oh yeah, you guys see that? If you, the shader, look at the edges, it's going from, look, we're using the coordinates to change the, you see that? Look at the edges. Actually, you know what, we should just return white. This is actually really cool. You see that? Like this is with from David's idea. Basically, you can instead of returning one set color, you can just change the color of the edges with that. So that looks really cool. Interesting. Times. This is where all the math fun comes in. Oh, yes! This is it. Yes! My favorite part of game development, which is basically making random stuff. Yeah, this is about as good as we're gonna get. Okay, we are going to talk about the artifacts in a bit. I just got totally carried away. Hey, Medium Unwell, what are you talking about? Research, work experience, residencies. Yeah, I mean, you know, a lot of those just came from kind of building up on a portfolio of work, right? It was like this thing with UIC and Video Game Art Gallery happened because I've been working on this game for three years now. Like my latest residency with UIC, this is actually my 6th residency. So I've done 6 different art residencies now, with the first one in Omaha back in 2010. So actually now I have to post that on Twitter. Yeah, thanks David for the rainbow colored edge detection shader. Anyway, I'm gonna come right back and explain this the artifacts. So, right. So this is what we're doing. We are comparing. Let me see some of these sections. Okay. So right. So we're comparing these two values to see if the normals are the same or different, and we're comparing these one to see if they're the same normal, or the same or different. Now, if it is, and we are going to do a new layer. Now, when the, so like here's an example, right? So what we're going to do is we are going to, let's say light blue. Let's say that this light blue, this is like one texture, right? So now these artifacts always happen when we have two pieces meeting. So to the edge detection shader, it is somehow seeing this. Right? Our edge detection shader is seeing, when it's reading the normal values, it's like, it's seeing this. We're getting this, like, this is all, each is one pixel. So, right, so what is going on here? So it doesn't, we don't need to tweak the levels of the normals because it's actually based on the difference. So we know that we're getting this one pixel that is different. Right? And I think now if it is now here's the thing that's interesting about, okay, so this is artifact. Now with the correct with the correct with the actual correct okay, so with the correct what is this paint area thing in Photoshop that everyone keeps talking about? I prefer doing it this way. This is what a correct normal thing is looking like. We're looking at the differences. This is the artifact, right? So I think the difference here is that when we look at our sampling, and again, what we'll do is we'll say, this is our sampling, right? Yeah. Okay, so this is the one we're looking at. We're sampling these. Now, what would actually happen with the edge detection shader is that if we know that it's an edge, what I would do is see, so these four would actually be the exact same when it comes to normal values, right? Whereas here, these four would not be the same with regards to the normal values, if that makes sense. So like, basically, like what I'm saying is, if these four, like we wouldn't compare them to the one in the center. If these four are the same, it's not a normal. It's not an edge, right? Because right now, although right now it is getting a difference. Okay, hold on. I think I know how to do it now. That should fail our first test. Can't I? It's not a shader artifact, it's an artifact in the normals, yes. Yeah, no, that is how the shader works, right? But there is no way, there is no way to get rid of the. Right now, what we are doing is I want to write a test inside the shader that would block out, that would, because those fake edges are these incorrect edges. They are slightly different than the correct edges, and I feel like if we can hone in on that property, then we can get rid of the artifacts. Perhaps maybe axis aligning a render pass. Axis aligning a render pass in orthographic view. Why would I want to do? Yeah, I am. No, David Kilmer, you're right. In the gap, we're getting an orthogonal normal inside the gap, and that's like a floating point thing. Jet user, I'm not sure why I would do the axis align render pass in orthographic view, or I'm not sure how I can bring that info into here, because it's. No. I get the orthographic projection part, but not how do I don't know how to connect the information. There would be another opposite normal right next to that. I think I know what to do. Because the other case here, right, is that we get No. See, I was gonna do, so Garland of Bloom, I was going to do the wider thing, but I realized I don't think we have to do that. We just have to, I have an idea now. I have an idea, which is, and it's not just about the wider. You actually don't want to compare the difference. You just want to make sure they're the same, and you want to do separate tests. You want to do, because here's the problem. So for this would work. If we do the X cross, this is going to work. But if we do so this way, then it's not going to work, right? So I think for this, we would need to do a test like this. And of course this is not perfect, but I think it's going to be close enough. I think it's going to help. It is going to help. I mean, I am basically doing that, right? So I know what I'm going to do now. I know what I'm going to do. I know what I am going to do. So, man, I think people are really digging that rainbow edge detection. I know what to do now. I know what to do. I know what to do. I don't even think we need the larger sample size. I know, and we are not using the blurring. We are not using the blurring. We do not need the blurring. Which of course means that all of this is no longer useful. See, I was doing the larger sample size, and I don't think we need to do that. Don't need to do that. Alright, okay. Alright, let's cancel this. Okay. This is it. I've wanted to be at this spot for a really long time. Okay. All right. Yeah, basically what Jet User pointed out, my problem was I had to blur so much, it was actually affecting the normal lines. So, okay, hold on a second. Let's get back into this. I know, it's so close. This is very exciting. It's very, very close. Very, very close. Very, very, very close. Let's just try to finish it tonight. I can't work on shaders anymore. It's driving me crazy. Okay. Okay. All right. So yeah, we can actually, you know what's great about this is we can see it inside the game. Oh man. Okay. By the way, has anyone here played Volume? Garlando Bloom, all this stuff you were saying is what we are doing. I'm a step ahead of you. Hold on, I need this in a separate screen. Okay, so see, we wanted to, I don't know if you guys can see it, but I wanted to zoom in far enough that we were seeing the edge, the Volume, it's the one, it's by Mike Bithell. It's, he made Thomas Was Alone. I was just curious if anyone here had checked it out. Alright. I know what it's gonna be, and it's actually better. So, artifact check. Artifact check. So if it is an artifact, we want this to become 1. So we only want to do the artifact check on the points that are edges. So if values are close, so if values are equal to 0, so that means the values are not close, therefore it's an edge. So we only do the artifact check when Hey, Synthoid Commander, how's it going? How come no one's heard of Volume? That's weird, because I feel like Thomas Was Alone was such a big hit. I guess everyone is just interested in very different things. Yeah, I was just kind of curious if that's something that something you guys are interested in, because it's described as a stealth puzzle game, but the puzzles are obviously very different from. So no, I got it. So if values are close equals to 0, so we are only performing this test on pixels which are determined to be edges. Oh, I see. Huh. Moving around edge walls and stuff. Well, if anyone plays it, I'd love to hear what you think of it. I've been playing NBA 2K15 a lot. That is my go-to game. So we only want to perform this test on pixels which are determined to be edges. Right? If values are close equals to 0, and what we want to do is half artifact check hold on, let's just make sure I'm not confused. If artifact check equals to 1, it is not an edge. If artifact check equals to 0, it is an edge, right? And what we want to do is this. No. Okay, artifact check A. No, wait, got it. Hold on. Artifact check X cross and half artifact check cross. If either equals to 1, if either artifact check X cross equals to 1, if either artifact X cross or artifact check cross equals to 1, it is not an edge. So, because the thing is, if we multiply them like what we're doing above, then if you multiply by 0, it's always going to be 0. Hey, Hey, yeah, medium unwell. Thank you so much. And also, I have something super, super exciting. I don't know if I should show it to you guys now. It's still a work in progress, and I don't want to promise anything I can't deliver. But, hey, Kaiser Finney. I'm not going to fully explain. We're basically trying to get rid of these artifacts, and I think we're just right on the edge of discovering a solution. We need to test it, of course. If artifact check rate. Now the thing is, eventually I'm going to come back and clean up. By the way, medium unwell, thank you so much. Thanks for coming here, and really glad to hear you're a fan of the game. Yeah, if you have any questions, just feel free to hit me up. If artifact check x cross equals to 1, or if either of them is equal to 1, then we know it's failed our test, which means then we need to invert. And yeah, what I'm saying is I'm going to come back. You want to get rid of the conditionals because I think you don't really want them in your shader. It's not, the GPU isn't very good at stuff. Cheater deleter, hello. Alright, see ya, talk to you later. Okay, now if either of these is not an edge, it has failed the artifact test check. And so we would want to invert values are close equals to 1. Right, so if values are 0, so basically if values are close equals to 0, we know that this pixel is, so this basically, if values are close equals to 0, we know that the shader thinks the pixel is an edge. We perform these two tests. If it fails either one of them, then we reverse the values are close result. And wait, let me check that this is right, okay, so we were actually getting a problem with the shader. Oh, fuck. Values are close equals to 1? What? Why? Values are close. Why is it? What do you mean it's undeclared? Oh, values are close. Wait, is this the right depth than normal? Is this edge detection depth than normal, right? So, and edge detection purse, it is depth based thickness. Of course, that's why it wasn't showing up. No, whoops. Okay, right. So hold on. Moment of hope this works. Okay. Let me see this. Interesting. Interesting. Look, we've fixed it a lot. Hold on a second. Let's do X cross. We're close. I think this is working. Yeah, I have it all archived. Um, Guys! Holy shit. Okay, we're losing some of the edges, but I think I got rid of the artifacts? Oh my fuck. What the hell? Okay, well, so clearly we're losing a lot of stuff, but holy shit, I think this is it? Okay, we're losing those, but holy fuck. Hold on. I feel like... Hold on, I think we've done it. I think we fucking did it. I think we did it. I think we did it. It is... We are getting rid of some of the normal values, but I think it's I think we did it. So I'm losing the edges here, which is a problem. Oh, no, wait, I think it's right. Guys. Oh, shit. I think we've done it. I think we've done it. Oh no, we're still seeing some of the... No, we're still seeing them. But maybe if we did... Maybe if we tried larger sample size? There has to be a way... So we're still seeing them. Let's try larger sample size. Let's try a larger sample size. Got too excited there. That was a depth thing, so the depth is affecting it. So let me try one more thing. Let's... Actually, you know what? No, 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 no. Yes, 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 yes. We got the test. We got the test. The test was wrong. Check same normal 4 samples artifact. We don't need it. We just need to. So we were comparing it to the normal. What we should have been doing is comparing it to itself. And I think we might need a different. Let's go with. Is sensitivity Z being used anywhere? Okay. Hold on, we're so close. We are so close. I think we're gonna do it this way. Oh, man, we are so close. This is so close. Edge detection purse. Hold on a second. Okay, that is fine. So I think this is going to work. We were doing the test wrong. What we really needed to do, so we don't actually need additional. What we do need to do is we shouldn't have been using this function. We needed to be using this function. Okay, well, it is, yeah, hold on. Sensitivity.z, Z is invalid? Oh, no, wait, I mean, okay, hold on. Ah, no, 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 because this one doesn't need the center value. Okay. I think this is it. Oh, man. Ah, right. So it looks like it is almost... Okay, so here we have the... Let's... Alright, so the problem is that we are losing the edges. So yeah, our test is getting rid of the artifacts, but we're also losing correct edges. So I think I know, so yeah, we've gotten rid of the artifacts. Yeah, like you can see that there are no artifacts, but we've also gotten rid of some correct edges. So that needs to get fixed, and I think, alright guys, so like, check this out, right? So this is what's going on. Okay. I know what we need to do, which is actually, we need to combine depth and normals. Oh, no, wait! Guys, we just gotta do the artifact test before we do the depth test. I did it! I did it! Guys, I did it! Oh my god! Holy shit! After 2 years, we did it! Wow, this has been 2 years. Oh my god. For real, it's gone. Well, okay, so you can see there's a little bit of it. So really, right? This was the main part. This was the main part. So yeah, check this out. Okay. Okay, I think you guys can see the artifacts, right? So basically, what we had before was, I was like, okay, so we were doing the test. We had the normal test, we had the depth test, and then we were doing these artifact tests. Basically, it was saying if the values are close, if we already decided that if we decide that the pixel is already an edge, then we run this artifact test, and if it fails our artifact test, we reverse the result, right? And so basically what we were doing, what was happening then, was we were losing all these edges here. And I was like, oh man, that's a problem. But then I realized those were edges that were depth-based, because those were the edges that were, the depth was the difference, right? They had the same normals because it's the stairs, right? It was this. So you can see this face, these two faces have the same normal. So if you're just doing the normal test, you're not going to get the edge, right? But if you look at the depth, well, they're going to be different, so you're going to get an edge. So I was like, oh no, wait, they're passing the depth test, and we are reversing the result of the depth test with this. And I was like, oh man, maybe we need to like do something else. And I was like, no, wait, we can just make sure we just do the artifact checked after the normal test, but before the depth test. And then look, and you see that? It's gone. You see that? Look. We comment this out. You see that? You see that? Look at those normals. You see that? We uncomment it out. It's gone. It's gone. It's gone. It's gone. 2 years, guys. I've been working on this. When was the first time, man, like... I've been working on this edge detection shader. I can't believe it. We did it. I did it. Wow. Like, when was the first time we talked about this, like, artifact issue? I feel like I've gone over it a few times. It's like I've been refining it for 2 years. I can't believe this. Look, we had the artifacts here, but I remember writing this blog post. Yeah, like this is February 6th, 2015, and Devin had looked at it then. Right, I had Devin take a look at it, but this was not the first time we did it. Oh, revisiting edge detection. So, see, we revisited in May 2014. So over a year and a half ago, we came back, but yeah, like here, look, this is a year and a half ago, and we are looking at all these artifacts, and I couldn't fix it. See, I know that this is a problem due to using normals and not depth values. Not exactly sure what the problem is, but I think it has something to do with floating point precision. They tend to occur at places where primitives are supposed to align. I'm guessing there's just some tiny difference in the shaders detecting a gap. During gameplay, these would flicker in and out all the time, which really bothered me. And I improved it a bit, but it was still... But see, Hey guys, wow, man, thank you all. This is kind of super cool that we caught it on the stream. There seems to be some artifacting near the pillar. Mega spell, no. Wait, let's go back and check it. One weird trick. Hey, Bam Cams. Thanks. Yeah, you picked. This is definitely the best stream so far. Hey, morning. Yeah, Ed Riofer. Yeah, Ed Riofer. We did it. Like well, no. So that's not an artifact. That's You're right. Mega spell. That's actually that's actually due to That is due to what's it called? That's a Z fighting thing. It's actually not that. Those are Z fighting pillars. It's Z fighting pillars. It's this. It's like it goes into itself, I think. Oh no, you see, that's what's going on. There's two of them. Yeah, you see there's two of them inside the that Z fighting. So but I can't believe it. When did I hold on a second. We're gonna end this soon, but I just want to show you guys when I wrote the first edge detection shader. This is one of the coolest things about having kept this devlog, is like you can go back and just see all this stuff. Like, so I know a lot of people have been asking questions about how long it took to get here, and yeah, so this was the image that gave me the inspiration, like this post. So this is March 31st, 2014. Today is August 18th, 2015. Right, I saw this and man, I can't believe it. We did it. So yeah, that's the Z fighting. So ignoring that, I did it. They're gone. And it looks so good. It looks so good. Holy shit. Wow. Okay, you see there, but that's actually not you see that? You see, so this like right up ahead, that's actually because there's a slight offset. That one I know. That one, there's like an offset with the geometry. It's like not properly aligned. Yeah, those are that's that geometry, because normally it's like not that clean. Wow, guys. Man. Alright, I think this is a good place to end the stream today. But that was like super cool to catch. Like this is swear to God not scripted, right? Like I talked about it. It looks so good. I knew it was worth fighting it. And you know what? I gotta thank. You know who I have to thank for this? Well, first of all, thank you all. Thank you everyone who was on the stream tonight, who's been on the stream, because I think like honestly, it was talking through all this, getting everyone's suggestions, that we finally gotten here. Like, God. But it was Lucas Pope. Last year I was at Tokyo Game Show, and I had Lucas Pope play the game. I actually like met him. It was funny. So I met Lucas Pope at GDC 2014, and my friend Sean Hogan. Sean made Anodyne. He was like friends with Lucas, and he was like talking to Lucas, and I was standing around, and he introduced me to Lucas Pope, and the guy had just won like every single IGF. He just like swept. He won like 4 awards that night. Right, and Papers, Please was like huge, and we were all like, I was just like, oh man, he's like an indie rock star. He's actually a really nice guy. He's like one of the coolest guys in the indie scene. And then I saw him at Tokyo Game Show again. He was like playing people's games, like it was kind of closing, and I ran up to him and I was like, dude, you gotta, Lucas, like we met at he's like, oh yeah, I remember you. And I had him play the game, and he's doing some edge detection with Oberdin, and he like played around with it, and I was like talking about the artifacts, and I didn't have to fix it. And he just turned to me and he's like, oh man, dude, you gotta fix it. And I was just like, okay, yeah, like Pope said I gotta do it, so I knew that had to happen. And it's just something, it's kind of like he really pushed me to, but like, I just want to try this out again, but we finally fucking did it. You see that? Guys, look. You see how ugly that is? Guys, you see all the edges? You see all the edge detection? We did it. We did it. I knew there was a solution. I knew it. I knew there was one. I knew it. I knew it. Yes. Okay. Look. This edge detection, it probably only works with faces constrained to the axis. It's not good if you have surfaces, but anyway, huge thanks to all of you. I am so happy. You have no idea. This has been this ongoing struggle for like for a year and a half now. And just to finally solve it, we did it. 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 It's so clean. It looks so good. It looks so good. It looks so good. Okay. Oh, comment Control K, Control C. Right. Thanks. Yeah, I know. There's that. Yeah, that's right, Bam Cam. I need to start getting used to that. I'm still not super good with the shortcuts. All right. Yeah. So basically, like, this one is a lot easier, right? What we are doing, we don't actually need to explain the code. Like, how would you do an edge detection shader? And the very basic idea with edge detection is you want to look at, this is your pixel, right? You're sampling through the pixel in your shader, and you're like, the pixel we're looking at is the black one, and we're just like, hey, how do I know if this is an edge or not? And you can do a normal test, right? So with the normal, we have, you're looking at this, right? This face and this face have two different normal values, and we can have this information from the depth normal texture. We can get it from the camera. This is information we can get normals, and we can get depth values, how far things are. So if we see, like, this is the border pixel, right? The pixel slightly over. Actually, you know what? Because it's really just easier with. Okay, this is an example, right? Come on, just open. Okay, so you see these pixels in the middle? These are the edges, right? No, the pixels to the left has one normal value, then the pixels to the right have another different value. So if we're sampling, we're like, okay, get this pixel, check the pixels to the left, check the pixels to the right. Are their normal values the same? If yes, not an edge. If not, it is an edge. And you can compare the depth values. So that's all we're doing, right? And what I realized, though, this was the realization today, was when we did this. And I said, okay, this is the correct pixel, right? If the correct pixel, if we're sampling it, these pixels that we sample on the right have one normal value, and these pixels that we sample on the left have another normal value. This is one of our artifact lines. This is one of the lines that we don't want. We know here that the pixels on the right and the pixels on the left all have the same normal values. So that's all we did. We just made sure that all four of these were the same. And that was it. That was it. So, Media Manuel, I hope that answers your question. Anyway, this was like super awesome. We did it. So it is getting late now. It's 10:30. So I'm gonna take off. If you're watching the stream and you enjoy it, definitely follow. This is kind of stuff that happens. Development is pretty open. Relativity game is the website. There's all the information below. I'm on Twitter, William Chyr, and we are going to have a new name for the game, just because Relativity doesn't really describe where it is now, and it's also like too common of a word. So that's all going to get announced next month. There's also something really, really cool. Actually, you know what? Just because it's been so awesome tonight, I'm going to show you something. I'm going to show you guys something before you guys go. I want to show you guys something, and I have to warn you, like, I cannot. This doesn't mean it's going to be in the game. Okay, I don't know if we can actually support it, but it is something we're working on, and I wanted to show you guys this, which is because David is awesome, but this is runtime. You can create a cube. This is all inside. This is not in the editor, okay? Right? You can create a cube. You can move it around. We can switch into geometry editing mode. You can set your world wrap's distance. You can set your position. You can set offsets. We can draw corners, duplicates. Let's create another one. Let's, again, I can't, this may not be in the game. I'm using it for a workshop, but David has been super awesome. It's still like super finicky, and file, we can save, we can load, hit play. All right, so my shader is broken right now, right? But so I can't show you this. But I'm like doing these workshops for architects to kind of teach them about some of the ideas with wool wrapping, and so if this works well and if we can support it, you know, I'd love to have an editor, but so I can't promise. I don't know if it's going to be in the game. One thing that's going to be really hard is making it adaptable to working with the controller, right? But it's promising. David did this in like 2 days, so but yeah, hopefully, you know, I'd love to, because the design process has been so awesome for me. I'd love to let people get that too, and so maybe we'll have like a GIF maker here. This is all stuff, but anyway, we are going to, I'm going to end it, and I will see you guys tomorrow. Oh yeah, so I was saying, yeah, just follow if you like the stream, and so normally I do weeknights, 8:30 to 10 p.m. Central Time. I think starting next week, maybe Tuesday or Thursday, I'm going to do earlier in the afternoon so people in the UK don't have to stay up super late. But thank you all for watching. I will see you guys tomorrow.